Hello everyone, I hope you're doing well. In this video, we are going to talk about Legendre differential equations and Legendre polynomials. This is an introductory video and I'm making this video with that objective in mind that I have to prepare you people for solving the problems related to Legendre differential equations. Okay, so I'm going to include all of the important information and relations related to these differential equations and their solutions, which we call as polynomials. Okay, so if the differential equation is Legendre differential equation, so its solutions will be called as Legendre polynomials. If the differential equation is, for example, Hermite differential equation, then its solution will be Hermite polynomials. So these are actually the special differential equations and the solutions are special functions and we give them special names. So it could be Legendre differential equations with solutions Legendre polynomials. It could be Legendre differential equations with Legendre polynomials as their solutions, and Bessel's function and so on. These all functions are really important in mathematical methods as well as in practical physics situation. They frequently appear in some of the important systems of physics, including hydrogen atom and whatnot. You'll see in hydrogen atom, for example, the radial solutions are actually the Legendre polynomials and their angular solutions are actually the Legendre polynomials. Okay, so understanding these equations is crucial in physics. So here, first of all, we'll see what is the standard form of these equations. The standard form actually helps us to identify Legendre equations because, as I told you people, that there are many kinds of differential equations. So for example, if you have tons of different kinds of differential equations, then how you can recognize that which of them is Legendre differential equation? You can identify them by comparing them with the standard form of Legendre differential equations. If those equations could be expressed in terms of the standard form of Legendre differential equations, then those equations will be Legendre differential equations, and those equations which couldn't be expressed in terms of the standard form will not be the Legendre differential equation. So it's really important for you people to know the standard form because it will help you to identify that which equations you are, like for example, the equation you are seeing is a Legendre differential equation or not. Identifying the type of equation solves the half of the problem. Okay, so it's really important. Besides that, the standard form also gives you that important parameter n, which is you'll see frequently used later on related to these equations. Okay, so that's how I can justify the importance of knowing the standard form. First, it will help you in identification of these equations itself out of all of the equations that are available on universe, and secondly, it will help you to determine the important parameter n related to these equations. Now let's see what is the standard form of differential equation, Legendre differential equations. There are actually two forms which are really close. Okay, so we'll see both of them so that we are familiar with all of the possible forms the Legendre differential equations could have, and we'll see the examples as well, that how we can identify equations using the standard form. Okay, so we'll see the examples so that you may have a clear concept about what is possibly gonna happen in practical situation. Okay, so let's see the standard form. The standard form of Legendre differential equation is, you write this on your own. This is bracket stars 1 minus x square. Okay, this is 1 minus x square y double prime. Y double prime means it's a double derivative of y with respect to x. Okay, it's like that situation. Okay, this is a double derivative. We are expressing it with prime sign. 2 prime sign means it's a double derivative. 1 prime sign will mean it's a single derivative. And no prime means it's no derivative, so it's simply y, the variable. Okay, so 1 minus x square y double prime minus 2x, we have 2x here, then y prime plus n into n plus 1 y equals to 0. Okay, this is the standard form of Legendre differential equations. I draw this line just to make you aware that it's a x dependent term, then we have y prime separate. There is no purpose of that line. Okay. This is the first form. We can see here these are the, this is n. Okay, and we'll see the example and it will be clarified to you people that how to determine it. Now let me mention that what are Legendre differential equations. So all of the differential equations which could be written in this form, in this standard form, are called as the Legendre differential equations. So they are a special class of ordinary differential equations which has this form. Okay, so all of the differential equations which could be expressed in this form will be the Legendre differential equations, and the solutions will be the Legendre polynomials whose form will be seen later on. So yeah, Legendre differential equations are just a name for a specific form of differential equations which we can see right on here in this paper. Yes, and another form, the second, in order to get the second standard form, what we do is to make the coefficient of y double prime equals to 1. Okay, for that purpose what we will do is to divide 1 minus x square by each of these values on both sides of the equation to make the coefficient of y double prime equals to 1. Dividing any number by 0 gives you 0, that is why I am not writing it here. It will become 1 now. It's y double prime minus 2x by 1 minus x squared y double prime plus n into n plus 1 by 1 minus x squared y equals to 0. Okay, now let the coefficient of y double prime is equals to p of x minus, including the minus sign. Okay, minus 2x divided by 1 minus x squared. Okay, that is p of x. And what is q of x? Let q of x is equals to the coefficient of y. We are just letting it to reduce it into a standard form. Now let's replace those values. Instead of minus 2x by 1 minus x squared, I'm gonna write p of x, and in place of this quantity I write q of x. So it will become plus p of x y double prime plus q of x y equals 0. This is the second standard form where p of x is equals to negative 2x divided by 1 minus x squared, and you can even write it as like, you can multiply the negative sign in the denominator, so it becomes x squared minus 1 as well. Then we have q of x, which is n into n plus 1 divided by 1 minus x squared simply. This is just a form that you should be familiar with. Okay, that has nothing to do with anything else. You should just know these two forms. This is the second standard form, and this is the first standard form, and this standard form is mostly used. Okay, here I have wrote both of these standard forms. Okay, here I wrote them in primed form, which is very convenient in writing. This makes the writing process way complex. That is why I really recommend you people to use this notation for derivatives. Okay, I have just replaced the primed notation with the actual derivative notation. It's totally up to you, but sometimes what happens is that the equation given in this form and you are not familiar in seeing the equations in this form, that is why you get confused. So you don't need to be confused. You have seen it now. Okay, so we can replace it by double derivatives and single derivatives as well. Here there should be plus signs in standard form, that is why I'm just taking the brackets here. It will be dy by dx here, it's dy by dx like that. Okay, plus n into n plus 1 divided by 1 minus x square. It's already plus here, there is no need to use the bracket here. Y equals to 0. So these are the two standard forms of Legendre differential equations, out of which this is the most common one. Okay, and they are almost similar. There is only one difference, that we have just divided this thing with the whole of the quantity. So they are almost the same with one difference. Now let's see the standard solution for Legendre differential equations. This formula will help you to find out the solutions corresponding to any n you have for the equation. Okay, the formula is p n as a function of x. Here n is determined from the standard form. Okay, we will express the Legendre equation that we have in terms of the standard form. Okay, we make sure that the coefficient of y double prime is 1, and doing so will reduce the equation into standard form of Legendre differential equation. After writing the given equation in standard form, will determine the value of n, which will be written here. Okay, right here in place of n. X shows that the variable here is x. Okay, it's just showing that this function is expressed in terms of variable x. Nothing else is conveyed here. It's just showing that it is a function of x, like Pn of x will be having a single variable which will be x square, x cube, or but something about x, multiplied, divided, and something like that by some constants. Okay, but the variable here will be x only, and this is actually the solution. We call the solution of Legendre differential equations as Legendre polynomial. Legendre polynomial is just a term that is used for the solution of the Legendre differential equations, and they are actually polynomials. They appear in the increasing powers of x, and that is why. And the solution is the summation sign from m is equals to 0. I'll make you people understand this thing, just trust me. Okay, m equal to 0 to n by 2 or n minus 1 by 2. Okay, I'll make you people understand why I have wrote this. Here the coefficient comes with a, in subscript you will write an minus 2m, then it is multiplied by x with power n minus 2m, same power like that. Okay, this is the standard solution for Legendre differential equation. Here we normally do is that we put the value of an minus 2m coefficient right into this equation, so that let me first write separately what is an minus 2m. This is actually the recursion formula. The recursion formula helps us to determine the values of all the coefficients. That's a general formula. This thing is equals to minus 1 to the power m, 2n minus 2m, sorry, 2n, it's n and it's m, bracket close, factorial, the factorial of this term, divided by m factorial 2 to the power n minus m whole factorial, then n minus 2m factorial. This is the value of this coefficient. Now let's put this value right into this equation to get the full form of solution. Pn of x equals summation sign. You can simply write this, but doing so gives you the clear indication of what values of m to take while expanding the summation. Okay, mentioning it is good for you, but you can write it like that as well. Minus 1 to the power m 2n minus 2m factorial. I'm just writing the value of a n minus 2m. Okay, here m factorial 2 to the power n minus m whole factorial n minus 2m whole factorial. It's just a constant. Okay, this thing is just a constant. This is the variable, which is x n minus 2m. Here summation runs from m equals 0 to n by 2. It will run from m is equals to 0 to n by 2 if n is even. Okay, if you have a Legendre differential equation and you determine the value of n and it's even, then the summation will run from m equals to 0 to n by 2. Okay, if n is even. But if n is odd, for example, if n is 3, 5, 7, okay, then what you gonna do is that you'll expand that series from m equal to 0 to n minus 1 by 2. You will put the value of n here, and for example it's 3. 3 minus 1 makes it 2. 2 by 2 is 1. So this expansion will occur from m equal to 0 to m equal to 1. Okay, so that is how it tells you. It's really easy. N by 2 when n is even, n minus 1 by 2 when n is odd. This gives the upper limit to the summation. Okay, so you have to expand it from m equal to 0 to the n value that is given in the Legendre differential equation that is given to you. Okay, we'll do it. Okay, you'll understand it very easily. It's this is the standard solution in the form of series. Okay, this is the standard solution of Legendre differential equations, which we call as Legendre polynomials. And there is another formula which is Rodrigues formula that we call, for example, I don't know how to pronounce it, but it's Rodrigues formula. Here it is. This is the Rodrigues formula in terms of derivatives. Okay, here we are seeing this solution is expressed in terms of series. We have series here, and this is really easy as well. When we'll apply it practically, you'll see that it's really easy to apply. You are just seeing this lengthy summation term and it scares you, but it has nothing to scare about. If you practice it enough times, then it will not scare you anymore. This is the Rodrigues formula. This is also a formula for Legendre polynomials. You can also use it to find out the solutions of Legendre differential equations. Both of these formulas are equivalent. Okay, they give the same result. Sometimes this is mentioned, so you should know that this is also a formula for Legendre polynomials. Putting the values, if you know the value of n here, put it and solve it, you'll get the answer. For example, n is equals to 2, you'll write 2 here. It will become the second order derivative. You'll take second order derivative of this term. Here n is in the power as well. Okay, let me write it by hand so that you may recognize the elements of it. Let us write the Rodrigues formula. Every special function has a Rodrigues formula, equivalent Rodrigues formula. It's Pn of x equals 1 over 2 to the power n, then multiplied by n factorial in the denominator, multiplied multiplied by d nth order derivative of what term? Of 1 minus x, oh it's it's x square minus 1, x square minus 1 to the power n. Okay, let me write it again. I messed up. Sometimes I just mispronounce the words. Okay, this is the formula. This is the Rodriguez formula for Legendre polynomials. And what else we have to say is that, for example, if n is equals to 0, this is the value of Legendre polynomial that you will get. We'll prove it in next videos because it's a kind of problem. Okay, they ask you to find out the values of Legendre polynomials for different value of n, taking different value of n only. So if n is equals to 0, this is the result you get. For n is equals to 1, you get this. N is equals to 2, you get this. N is equals to 3, you get this, and so on. What is the range of convergence of Legendre differential equations? In general, it's -1 less than x less than 1, means from -1 to 1. This is the range of convergence for Legendre differential equations if they have infinite series solution. Okay, if we have infinite series, then we are concerned about the range of convergence. But if we have finite solutions like Legendre polynomials, then we don't have to consider the range of convergence because they are converging for all values of x. And that's the good thing about the polynomial solutions, because they are finite and they are true and converging for all values of x. But if we have the infinite solutions, then they have to be considered for a range of x values like -1 to 1. I don't know if you have already solved the Legendre differential equations using the power series method or not. If you do, then you'll come to know that the Legendre differential equations have two actually solutions. One is the finite solution and another is the infinite solution, and both of them are the solutions of Legendre differential equations. We only consider and are interested in the finite solution, which is the Legendre polynomial, because it is converging for all values of x. Okay, and there is no issue with the convergence, because the issue of convergence occurs with the infinite series, because the issue of convergence only appears with the infinite series, which is this solution. And you know that we really talked about it because it's least important. More important is the Legendre polynomial. Pn of x is the finite solution, y2 of x is the infinite series solution, and if we have two linearly independent solutions, then the general solution is actually the linear combination of both of these solutions. Okay, that is how I have wrote them like that, and you should know about it. Okay, so yes, this is something that you should know. Now you know the standard forms, the two standard forms here. Okay, the standard solution. Now you know the standard solution. This is the standard solution. Okay, this is not the standard solution. This is the standard solution of Legendre differential equations. If you are asked about, or if it is mentioned, then you should know that this is the standard solution in this series form. This is alternative formula for the solution, Rodriguez formula, and they are normally used in proving the orthogonality condition for Legendre differential equations. We'll see that as well later on because it's a kind of problem related to them. And yeah, you know all about Legendre differential equations. Now we'll step into the problem section where we'll solve different kinds of problems related to Legendre differential equations. Stay tuned. Goodbye. If you have any question, you can ask me in comment section, and I'll put all of these videos in mathematical methods of physics playlist. you can easily go in the playlist section of my channel and you'll find these videos there, or I'll put the link of that playlist in the comment section. You can easily check it out. Goodbye.